Welcome to Walkabout the Galaxy, the high-tech astronomy podcast where the science is universal, the opinions are personal, and the hosts' voices are sparkling.
Shing!
We are strange, charm, and down the Astroquarks, also known as Josh Caldwell.
Addie Dove.
And Audrey Martin.
Coming to you from the new Walkabout studio at the University of Central Florida. Subscribe to us on Facebook, Instagram, and YouTube. You can contact us at wtg@ucf.edu with questions, suggestions, and compliments. If you would like a Walkabout t-shirt, email us for instructions. I think that's better than actually sending you off on a crazy... Then it's more like a challenge. If you can actually figure out how to get a t-shirt without me emailing us, well done.
That's true.
Anybody getting a t-shirt in the next period of time will get free random NASA patches.
Ooh, we do have...
I have a supply.
Random supplies of those.
Yeah. Our stumper today is also inspired by the Olympics like last episode, but I'm taking it beyond the realm of the Olympics this time.
It's too much. Okay.
So one of the things that happens in the Olympics is world records get set.
Sure.
So there, and I don't know, when I was a kid, I loved getting the Guinness Book of World Records and reading about all sorts of crazy things. And at one time I thought I was going to...
I had that too.
I thought that I had set our presets on the microphones to sparkling, but I detected sarcasm.
It was a hint of sarcasm.
There. I
added a filter.
have to turn that down. When I was a kid, I thought I was going to set the world record for coin snatching.
What does that mean?
Excuse you?
Yeah, you put a stack of coins on your forearm with your elbow held up and then swing down rapidly and catch them all in your hand.
Oh, that just sounds like you're a pickpocket.
It does sound
coin
like
snatching.
coin
Okay,
snatching.
you just wanted to
How
be
many
the
could you
world's
do?
most successful pickpocket.
I did 40-some pennies. And then
that's
it's a
really
lot.
good.
Yeah, but then
You should have made it dimes. It would have been worth more.
Well, I discovered that the world record was actually for quarters.
Sure.
And my little boy hands were not up to
Have you tried doing that recently?
No.
You should try.
Well, maybe this will be what your stumper response is. If you could be the world record holder in anything that there is a recorded world record in, what would it be?
This doesn't have to be something I'm actually good at. This is what I want to be good
that's
at.
right.
Aspirational.
I forgot to
Prep for this.
think about it.
Yeah. That's okay. It's more stumpery this way. This is always the most exciting part where we just sort of stare off into space while we think about our answers.
Audrey takes these very seriously.
We should.
Well, so what comes to mind is maybe it might be I don't think it's not in the Olympics. But vertical
Doesn't need to
jump,
be in the Olympics.
No, anything.
I want to jump
you want a good vertical.
taller than anyone ever.
Just from your feet, not with a pole vault or anything like that.
Yeah, because people have dreams about flying and stuff.
Yeah.
When I have dreams that are like those, I bounce.
You want to be bouncy.
And so that would be really cool. But I know
you should
I
go to the moon. You're pretty bouncy.
I know
on the moon.
that would be kind of fun. But then I'd have to go to the moon.
Yeah. Okay.
I feel like mine would be...
So standing high jump or something like that is
That's
Audrey's.
so boring.
I really want some sort of eating related one.
Oh.
Like I don't want to be a professional
Eater.
eater, but I'm always so impressed by how they
the
can
hot
put
dog
down
guy.
food. Not the hot dogs, but
The beers
other things.
or something.
Yeah, one of those. I just want to
Interesting.
I really like eating food.
Their pre-game regiments are really weird.
There was a great YouTube channel we were watching for a while that's this little tiny woman who professional what's it even called?
Eating
contests. Yeah, she does. So she'd go to restaurants that had challenges and things like that, and do YouTube video eating it, and it's so impressive.
Wow.
It was a random.
That is random. I was
A different day, I might have a different answer for this question.
Oh yeah.
I was thinking more
Maybe I'm hungry.
Something Olympics
Sure.
running.
No,
or
mine's
something
just
like that.
eating.
But maybe I should do something like.
What's yours?
Yeah, maybe it should be world record for chess rating.
Oh, yeah. You could be a chess grandmaster.
Or fastest Rubik's Cube.
Do you want to be a speed chess or
speed chess? I don't have that. It takes the other takes too long.
Yeah, speed chess.
Both are hard.
Yes, the highest rating for 5-minute chess games.
Yeah.
Today,
Okay.
Today we'll talk about water, asteroid impactors, and much more. But first, this episode of Walkabout the Galaxy is brought to you by water.
Thanks, water.
Whether you want fun, relaxation, to cool off, or just to feel better, look no further than water, bringing you life, swimming, beaches, babbling brooks, and roaring waterfalls, cool refreshment, and hot refreshment for that matter. And did we mention life? Water has what you're looking for. From giant molecular clouds in interstellar space to buried reservoirs scattered around the solar system, water, or oxidane, hydrogen oxide, hydrogen hydroxide, call it what you will, turn to water for all your essential needs. Available in vapor, liquid, and a dazzling variety of solid forms, make sure you've got the water you need to achieve your goals in life. Water. Don't leave home without it.
I even had my prop water here conveniently.
Visa.
I think you're...
American Express.
Who paid you to tank that one, Audrey? Do they still use that, American
Don't
Express?
leave home without it? I think so.
Yeah.
I have no idea.
Yeah.
I've had an American Express for a long time, so that's why I know that one.
Space news. So NASA had a press conference about Starliner
Yeah.
Oh.
where they said there's no news really.
Yeah.
We're still thinking about it.
Yeah.
Well, what are they thinking about?
When those folks are coming home and on what vehicle.
Yeah.
So they haven't even really landed on anything.
The space station.
Good one.
That's docking, not even landing, though.
They haven't docked on anything.
Yeah. They haven't. It's like I was team
I'm not sure if you're messing with me or I'm messing with you.
the
Both?
first both of them. Yeah,
Okay.
both of them. I was always team like it's all fine until maybe this last week or so.
Yeah.
It's just like I totally understand them. Like it's one of the few times where we've seen sort of the NASA review process play out in real time, right?
True.
Like when there are mishaps and when like the SpaceX thing, right? Their rocket didn't work properly not that long ago. Their
Right.
like main rocket booster that is the thing that
Falcon
also
9.
would be sending up humans, by the way.
Yeah.
Didn't work recently. And it was like that. There was some sort of mishap investigation, but most of it was behind closed doors, right? And all of this is behind closed doors, but we see the sort of implications of it and people are expecting updates all the time. So there's sort of a more real time playing out.
And also there's like two real people in
Yeah.
a real spot.
Yeah.
And like, not that it, like, they're doing okay, but like everyone cares. Like everyone is like, those people.
Yeah. And it's interesting too, like to think that like NASA didn't really, even though they knew this was a test flight, they didn't really maybe have a backup plan if it didn't work.
That's a good point.
Like, but think about when they did the SpaceX test flight. Like, what was the backup plan then if it didn't work?
Right.
Was there
Because
one?
then it would have had to have been like they'd come back on a Soyuz at some point,
Yeah. Who knows when?
but who knows when, right? Like,
yeah. Oh. Yeah.
I'm really curious about like what contingency plans they had for that set of flights.
Right. Right. Let's see. Other space news. We're still awaiting, I'm at least eagerly awaiting, Integrated Flight Test 4, speaking of SpaceX,
Yep.
for their Super Heavy Starship combo.
Yeah, I haven't seen any updates, but I haven't looked either. So
Last I've seen, it's sort of, they're talking end of August, as probably means early September.
yeah,
And presumably with a chopstick capture, et cetera, and all that stuff.
Yeah.
Lots of activity there. Well on the way to having a second launch tower constructed out there in Texas for these giant rockets.
yep. There's
Europa Clipper.
Oh yeah, the Clipper.
Clipper news is sort of news, but not news. It's sort of like we're still waiting for another weekish. I
But I
think.
don't think we've discussed this issue before, have we?
I don't remember.
So Europa Clipper is NASA's next flagship planetary mission. So one of their sort of, it's not led by, a particular scientist. It's an agency effort like the Mars rovers, like Cassini. And this one is going to orbit Jupiter, but its mission is to study Europa, which is one of what we call ocean worlds, because it's got a lot of subsurface water, a theme in today's episode. And there's a problem with Jupiter, with spacecraft at Jupiter.
It's got a lot of radiation. Yeah.
Right.
In Jupiter.
Yeah.
So
So I mean, like when you launch something from the Earth, it's no longer in the Earth's protective atmosphere, but that's not the important part necessarily. Part of the radiation is the atmosphere, but the other part is the radiation belts. So then the magnetosphere that surrounds the Earth and protects us from all this nasty radiation.
Yeah.
But as soon as you send things outside of that they're exposed to radiation. This includes things to tow the moon, by the way.
Right. So
Low Earth orbit is generally safer. Some other satellites in higher orbits do get exposed to a lot more radiation.
Yeah. So, and radiation is another one of the many examples where physicists have done a bad job of naming things.
Yeah.
Because when you think about, lots of times we're talking about radiation, we're talking about light.
Yes.
But for the most part here, we're talking about particles,
Yeah.
high energy, typically protons and electrons that are moving very quickly, and they can just plow right through solid material, and they eventually are absorbed or make contact with something. And if it's electronics, it screws up your electronics.
Yeah.
And so they're talking about radiation-hardened electronics.
It's really important for spaceflight is having radiation-hardened electronics. So it's like electronics that are built especially to withstand radiation. Oftentimes this comes with like a little bit of extra shielding on the electronics or other protections in the build hardware.
And then like when they manufacture it, they do
a lot of testing.
Yeah, they're typically sort of less performative than the thing that's in your desktop computer because they're bulkier and they've got more material in there to protect them against these charged particles. And the thing about Jupiter is it's got a very strong magnetic field.
Yep.
And so it has a very big magnetosphere that gobbles up all the charged particles coming from the sun. And then it has this moon, Io, that is spewing its volcanic material in the form of sulfur atoms into orbit around Jupiter, and those get ionized by this radiation and trapped. So it has lots and lots of particles trapped in there. So if you're orbiting Jupiter, you're flying through all these radiation belts. They're the sort of Jovian version of what we call the Van Allen belts here at Earth.
Yeah. And the current mission at Jupiter, Juno, that was expected to have a pretty short lifetime, partly because of this, was because they were going in pretty close to Jupiter to study Jupiter itself and also the moons and things like that. And it was going super close. And so they knew it was going to be exposed to all this radiation. So they didn't expect it to have a very long lifetime. It was going to spend a pretty long time in close to Jupiter. When it had an issue after launch.
Right.
I forget exactly what the issue was now at this point. I think it was another fuel issue. They had to modify the orbit that it was in and actually made it be in a longer orbit. So it's outside of the intense radiation more. And so it's actually been able to sort of have a longer mission because of that.
Yeah.
Which is interesting.
It's similar in some ways to what we do with the Mercury missions because you're very close to the sun, but Mercury itself is very hot. And so those spacecraft, when they're close to Mercury, their sky is filled with a giant hot rock. And so they don't cool off as well. So they have to spend a lot of time far away from Mercury. So the Messenger spacecraft was also like in a similar kind of orbit to Juno, mostly very, very, very far away from the hot thing, and then dip in and take some pictures really quick and then run away where it's nice and cool. The Jupiter orbiting spacecraft do the same thing. It's like mostly far away outside of those dangerous radiation belts, and then quickly dip in, take some pictures of Europa for the case of Europa Clipper, and then fly back out. So the whole tour is designed that way. And the problem is that people who were using the same transistors that are supposed to be radiation hardened for Europa Clipper started reporting just this year, this thing stopped working. And it wasn't getting as much radiation as there is at Jupiter. And so,
It wasn't the same. Well, I guess the instruments are different than what's on Juno.
It's just
it's
the
these
parts.
like transistors,
it's these particular
little
parts
tiny electronics chips.
were failing in lower radiation doses than what they were rated for and what they're expecting.
But there's been a lot of testing since this was found out, and I think the current thought is that like hopefully they're going to be able to proceed with it. The other thing, I think we did talk about this one time, so sorry if you're getting a rehash, but like it's like they bought the same batch of these things for everything, for all the instruments, for the spacecraft, for everything, because they knew it was this like great radiation hardened chip. And so it's on the spacecraft. It's on like they distributed them to the instruments, and the instruments were building their electronics.
Yeah.
And so it's like a system-wide issue.
Yeah. So we don't know if it's going to launch still.
I think we should find out very soon from what I've heard.
If it doesn't, that just means it's going to be delayed. It doesn't mean it's not going to launch, right?
Well, it's scheduled for October 10th is when the launch window opens. And for a launch like this going to Jupiter, it depends on where the planets are with respect to each other. No. So if they say, okay, this is a problem, we have to fix it, we're not launching in 2024.
Yeah.
We're taking the spacecraft off, we're replacing transistors, and we have to wait until literally the planets align again for our next launch opportunity, which, because we're launching from the Earth, it's at least a year, right?
Sure.
The Earth has to come around, and then you have to see where's Mars and where's Jupiter also.
Oh, my God.
Yeah. So that's dramatic.
Yeah.
Former top quark Tracy Becker
She might have something to say about it. We're hoping she's coming out for that launch, so.
Right.
And the rest of the Clipper team, so.
Yeah.
The other thing is other spacecraft news. NEOWISE is a spacecraft that's been had a long history now at this point. It was originally the WISE spacecraft.
So wise.
It was so WISE. It's an acronym for something.
Wide Field Infrared Survey Explorer.
Yes, and it was like an astrophysics-y mission.
Yep.
And then when it sort of finished its primary mission, it ran out of coolant, I think. Yeah. They repurposed it as NEOWISE to look at asteroids and near-Earth asteroids.
Near-Earth object WISE.
Yeah. To like do basically planetary defense and protection.
Yeah.
Find all those near-Earth objects.
It's sort of, in some sense, similar to JWST in that it's looking in the infrared. And so that's why it needs the coolant. They ran out of coolant, so they couldn't use the long wavelength stuff, but they could still use the shorter wavelength. And while they were looking at all these astrophysical things, they noticed, gee, these asteroids keep getting in the way of our pictures of galaxies and stuff. And so they decided to so it's actually going to burn up this year. Did you know that?
Yeah. That's what we do with a lot of spacecraft is we deorbit them.
So this one is deorbiting, I think, whether it wanted to or not.
Yeah, it probably ran out of fuel.
That's what it looked like in the article that I saw.
Yeah, it wasn't in a super high orbit to begin with, and with solar max, the Earth's upper atmosphere is puffed out a bit, and so the drag has increased, and it's now down at just a couple hundred miles up, and is expected to burn up.
But there'll be a new telescope going up pretty soon. Hopefully, NEO Surveyor, NEO.
NEO Surveyor.
Yeah.
Right.
And that one's gotten good funding profiles, even in more recent budgets that have been cutting funding for other things.
Yeah, I think because it falls under defense as well. So
yeah, it's not funded by defense, unfortunately, but it's.
Oh, it's not?
I don't think so. It's planetary defense.
Planetary defense.
Oh, but
Yeah. So speaking of planetary defense, it's looking to identify potentially hazardous asteroids that may hit the Earth, and that's a good thing to do because we know that asteroids. Did I say asteroids?
Asteroids.
Asteroids.
It's a silent H, Josh.
What?
Asteroids have hit the Earth in the past, and
Name one.
Are those pasteroids?
Pasteroids.
I'm glad you asked that, Audrey Martin. One asteroid that hit the Earth was about 65, 66 million years ago.
Name it.
Does it have a name? I don't think that asteroid has a name.
The Chicxulub crater asteroid.
Henry, Alice, Mark.
Chicxulub.
Chicxulub.
Barney.
Barney.
Oh,
great.
Because
Barney.
dinosaur.
Yep, I'm going with Barney.
I like that too.
And so Barney was about a 10-kilometer diameter asteroid. There was some debate about is it an asteroid or comet.
Sure. Space rocky
really
thing.
Same thing.
Hot take.
I know.
Cold take.
There's originally discovered this idea that this is what happened that resulted in this mass extinction from looking at elemental composition in that particular geological layer and noticing an abundance of iridium that corresponded to asteroids and not to what we typically find in the Earth. And it wiped out a whole bunch of stuff.
Yeah, and that thin band of rock is at what's formerly known as the KT boundary.
Yeah.
Which I've called it that for forever.
Yeah,
Me too.
it's always been the KT.
Until today.
Until recently, apparently it's called the KPG boundary.
Is it the what?
So it's because
when did that happen?
So for the K, first of all, so it's the Cretaceous / something boundary. So the K, first of all, actually comes from Creide, Kreide, which means chalk. because Cretaceous is derived from chalk.
Yeah, because the word Cretaceous actually starts with a C.
Yeah.
Yeah.
So it's actually, so the KT boundary was the Cretaceous Tertiary boundary, and the
tertiary.
KPG boundary is the Cretaceous Paleogene boundary, and that has to do with the fact that the eras versus, because it was actually meshing up different amounts of time.
Yeah.
So Cretaceous and Tertiary are not the same amounts of time.
Yeah, there's different
was
categories
sort
of time in geologic history.
It was sort of like calling something the 20th Monday boundary.
Yes,
for
exactly.
the boundary between the 20th century and Monday or something like that.
Yeah. Okay.
That makes sense.
That's kind of fun.
It's been discouraged as a formal geochronological unit by the International Commission on Stratigraphy. Anyway. We went into it. I like words and knowing word origins, and this is a fun deep dive into why did we rename it recently? And also people get mad about this kind of thing though when they get renamed, when dinosaurs get renamed and stuff like that.
So it's the Cretaceous Paleogene.
The Cretaceous period is the last period of the Mesozoic era and marks the beginning of the Paleogene period, the first period of the Cenozoic era. Thank you.
It's an eras tour going on today.
That's right.
So the news is that
not just that it's been renamed. That's not the news.
But it's
but
really,
that's the thing that we find most upsetting.
Yeah.
Clearly, yeah. But it's really cool because this boundary, this specific boundary, whatever it's called, KPG, is really...
Is that great Korean PG?
Kilometers per gallon.
Yeah. You can see it in a lot of different places on the continent and...
Which continent?
On this...
Any continents.
Any continent, actually. Most continents.
Definitely on North America.
But also Europe.
Mm-hmm. Also Europe.
It was discovered.
Because the iridium we've seen worldwide.
So, and so this particular boundary and also other geologic boundaries, but this one pops up in a lot of outcrops in all over the place. So we can determine, so this boundary and this boundary here, they happened at the same time. So if one is there's a lot of, faults in it or something, there was tectonic activity happening over here and not over here. And so it makes for very good geology.
Oh.
Yay.
Have I told you the story that, so the original...
Maybe not Audrey.
The original iridium was discovered in a road cut in Italy near Gubbio, and by Walter and Luis Alvarez. Okay. And I got to visit there at a meeting a long, long time ago, and in a country far, far away. And
Italy?
And I have a piece of that. I have at least atoms from that asteroid here in the office.
Where? So cool. Where?
It's in that box that I haven't unpacked from my office move.
My God.
It's behind the camera.
You could just scoop in there, and the layers are, a centimeter.
I want to hold it.
So I got some out. So there must be some atoms from that asteroid
That's amazing.
in there. And now they've taken a look at more atoms.
Yes. Back to our story.
Yes.
Right. And they looked at a different element.
Which one?
Something.
We all got so distracted by
something.
Ruthenium.
There it is.
What is it?
Ruthenium.
Oh, that's right.
And that's apparently super rare.
It's so vanishingly absent on Earth that it takes only small amounts to associate it with the impact by a carbonaceous type asteroid.
Right. So the discovery is that the abundance of this particular element is consistent with a carbonaceous asteroid instead of an S-type asteroid, which is a silicate. So it's
more silicate rich.
More right. So the main belt of asteroids is like rocks, silicate, and further out in the solar system, have more volatiles in them, so you have more carbon composition. So this is where carbonaceous chondrites. I'm out of my depth here.
So
Audrey. I'm looking at you with desperately pleading.
You keep saying words though, so
throw me a lifeline.
So the main asteroid belt has there's a lot of S types. So that's like rocks that you just think of. Think of a rock, and it's probably silicic. And then there's C types, which means carbonaceous, and that just means that they have a little bit more carbon.
They're more like charcoal-y.
Mm-hmm. They're darker, and they're considered more primitive, which means that they have undergone less heating and alterations in the past. So it's thought that they formed further out in the solar system, but we find them in the main belt, in the main asteroid belt.
So it looks like this. It looks like Barney was a carbonaceous.
It looks like
Yeah.
Barney was
Asteroid.
carbonaceous.
And a lot of the asteroids that hit us on Earth tend to be more silicic. They tend to be
Right.
more of the silicate asteroids, maybe from the main belt and things like that. So the fact that it's carbonaceous means it's probably more rare sort of in this area.
yeah.
And maybe, but more information for us to narrow down where it came from, which family, which asteroid family it maybe came from.
Yeah, or maybe it was like ran into Jupiter and Jupiter flung it with gravity and then woo, straight into Earth.
Good job, Jupiter.
Yeah, nice one.
So before we,
There's some we don't do what did we used to call it?
I don't know.
Science, not
Nerd
science.
News.
Nerd news. We don't, but there's some new movie coming out called like Slingshot or something. I'll Google it really
okay.
quickly. I'll DuckDuckGo it really quickly. And it's a different search engine.
Okay.
I
I was like thinking, is that game that I didn't
that
believe
game that you
existed?
don't know of. Yeah. Yeah.
Yeah, it's very close.
Anyway, we talked about slingshotting. That looks, oh man, we should watch it.
Like in a
we
like
should
in a
have
good
it.
way or like in a bad way?
No, like in a bad way.
Oh, okay. All right. So we'll cue that up. So before we talk about water on Mars again, our trivia today is about large numbers of things that don't have to do anything to do with each other. Okay. So it's a very simple kind of trivia.
I'm gonna read I'm gonna read the thing real quick. The IMDb description of Slingshot.
Wait,
really quickly.
who's directing it, or is it just
Casey Affleck is in it. Lawrence Fishburne is in it.
Oh,
Tomer
Oh.
Capone. I don't know who that is.
Man,
Writers are
what a-
R. Scott Adams and Nathan Parker.
What a roller
Director is
coaster.
Michael Hafstrom. I don't know how to say it. An astronaut struggles to maintain his grip on reality aboard a possibly fatally compromised mission to Saturn's moon, Titan.
okay.
ooh?
Well, I love a mission to Titan.
Yeah,
Anyway,
but not.
I want to see about a mission to Titan. Which is a bigger number? This is a Jim Cooney style.
Oh man.
We're expecting Jim back next or in one of the next two episodes. Which is a bigger number? Ready? You got 5 choices.
Okay. Wait, do we have to put them in order?
No.
I'm confused. I'll listen.
Which is the biggest?
Let's just listen.
Oh, okay.
Which
Okay,
is
bigger.
which is the largest of these 5 numbers?
Great, thank you.
Numbers?
I thought this was an easy trivia. The number of grains of sand on Earth.
Ugh.
The number of stars in the observable universe. The number of molecules in a drop of water. The number of neural connections in the human brain.
Right now.
Or the number of living cells on Earth.
Whose brain?
Mine.
Because I have
right.
very few neural connections right now in my brain.
So we'll come back to that, and I'll give you your choices again after we hear not about water on Mars, but this time water in Mars.
Water in Mars. So once again, we have found water
In Mars.
in Mars.
This time it's in Mars.
Yeah, and it's kind of exciting. So the InSight lander, thank you. Yeah, which that's I think the most exciting thing about all of this, because InSight, which launched like 5 years ago,
More.
I saw it launch. That was the first launch that I ever saw was InSight.
Aw.
It was really cool. So InSight, it went to Mars. It wasn't the best of missions. It had a couple of things go wrong. It landed in a crater, and it didn't mean to, apparently. It was trying to probe into the regolith on Mars, and the regolith was too soft.
We've had many discussions about the ill-fated mole.
Yeah.
Yeah, and so the
heat probe.
The heat probe, but it has a seismometer on it,
But it did some good seismology.
and it is continuing to. Yeah.
No.
It's dead.
Well,
done.
no, it's dead, but the results are coming out.
Yes. People are still analyzing the data.
Yeah,
It is no longer operational.
It is dead. Yeah, because
Because of dust.
of dust.
Because it was dusty there,
Yeah.
it turns out. And it didn't
Well,
get...
and they
it
went
didn't get like dust storms
Didn't
like
get the
other
windstorms
places
to clear off
do,
the
and
solar panels.
right,
stubbles
Right.
and
and
stuff like that.
but they did. That was a part of the plan. I learned this yesterday. They didn't want to go anywhere that was windy because of the seismometer.
Yeah.
Seismometers are really good wind
detectors.
detectors. And so they
Right.
wanted to go somewhere pretty pretty quiet.
Womp womp.
Yeah. Anyway,
None of these missions are intended to last forever.
that's true. That is
Usually
very
they
true.
last way longer than they're supposed to.
Right.
Yeah. But so using
3-hour tour.
it lasted more than 3 hours.
So did
3
Gilligan's.
days.
Water on
Adventure.
Mars.
So there's water on Mars. Using the seismometer, some researchers were able to find not just a little bit of water, but apparently a lot, about a mile. What is it? Let's see.
A global ocean a mile deep.
Yeah, a global ocean that's like on average a mile deep within the inside of the planet. So it's not on the surface. There's no water on the surface. There's a big canyon, Valles Marineris. There's no water at the bottom of the canyon. It's deep inside the surface. What did we?
And it's not unlike Europa that we were talking about earlier, which actually has a liquid ocean beneath the surface with vast quantities of liquid water that you could drive a submarine through. Do you drive a submarine? You could have anyway.
Navigate.
This water it's liquid, they say.
Yeah, it's liquid.
But it's not in a giant subterranean or subaerian pool or ocean or anything
It's like wet.
that.
Right. It's like muddy dirt.
If you sucked it all up somehow and deposited it on the surface, then it would be enough to make this giant planetary ocean, which I am astounded by.
Yeah.
It says it's 7 to 12 miles deep in the Martian crust.
Yeah.
I mean, we have a lot of water in
is-
our crust.
Yeah,
yeah, definitely. But it's
But if you take a look
If you want to make a flaky crust, you use vodka.
if you see these graphics that show if you took all the water on Earth and put it as a droplet and compare that to the size of the Earth, it's small.
yeah.
Yeah.
It's really not a lot. It's not so much. And
And then they scare you and they do all of it, but it's fresh water and it's really, really, really small. And then you're like, oh God.
but like a global ocean a mile deep, that's kind of like Earth.
Yeah.
I mean, our sort of we're 70% ocean, and I don't know what the average depth is, but it's on that order of magnitude, right? The deepest oceans are several miles.
Yeah.
So it's not Earth is bigger, so it's more water that way. But in terms of compared to the planet, so I'm kind of like astonished.
Yeah.
I mean, so one of the things, right, is that like they have this measurement at one location and it tells them about the interior and the surroundings. And so this like global thing is like an extrapolation to if that was everywhere in the subsurface. So it might be that they happen to be in a slightly more watery area, I think. But
they're looking at the. I mean, the way they figured this out is from the transmission of waves, seismic waves through the planet. So their seismometer is local, but those waves are coming from like some rumbling on the other side of the planet that's traveling through the planet to get to the seismometer.
it's still not a global measurement, though.
Yeah, but the problem is
because
they
it's
don't know where.
surface. Right. Yeah.
But they don't know where the rumble came from because it's one station. So
right.
they only have one station. If there were three, then it would be a lot more accurate and have a better
Triangulate where the signal came from.
Yeah, but because there's only one seismometer, it's definitely harder to tell. And I think there is a bit of averaging and some assumptions that have to go into it. But it's still interesting, and I think it means that there's probably going to be a couple more seismometers that are going to be tossed up to Mars pretty soon.
Yay.
I'm assuming.
Yeah.
But it's interesting for like the astrobio kind of bent, how there is life on Earth and really like hard to live places deep in the ocean and really hot places and everything, and maybe there's also life on Mars right now. It's hotter down there. It's shielded from the radiation, and there's
Maybe all
water.
the life
the water's
went
liquid,
down
yeah.
underground.
Yeah.
Yeah.
So there was a mission proposal to go to Mars some years ago. Didn't get selected. A different one do the same thing. Was selected. Was called the Great Escape because it was studying the loss of water from Mars, because we have all this evidence that we've talked about before of ancient riverbeds and shorelines and oceans and lakes and such on Mars. So we knew there was at one time a lot of water on the surface. that one time, by the way, about 3
Long
billion
time
years
ago.
ago. Yeah. So we have generally talked about that water went to space.
And I think a lot of it still did.
A lot of it must
And
have.
that's what
Yeah.
Maven has been trying to understand is like current water loss to space and what that means for the history of Mars.
Right. And so a lot of it went
some of
away
it might have
because the
been retained
magnetic
underwater.
field that we talked about
Underground.
before was
Yeah.
gone. So then you could have more sort of high energy particle sputtering of the water molecules away from the atmosphere. But some of it trickled down
Apparently.
Yeah.
through the
Through the rock.
Through the
through the sand,
sand
and
and
stuff
dirt
and
and rock.
has collected. But yeah, you're right, Addie, that
Yeah.
this is one measurement.
Yeah.
Right.
Yeah.
So that mile deep ocean,
When it's-
maybe we got lucky.
Yeah,
with
maybe.
where
I mean,
it's
it's like the Galileo probe, right? That
Right.
went into Jupiter.
yeah.
Was like it detected a bunch of water or no
It was
water.
it was a very
like
dry
very
spot.
dry spot, and it was just like maybe, but probably statistically from our other measurements, we think it was just like we got
Abnormally.
unlucky
Yeah.
with that drop zond, basically, right? So like I don't know.
Yeah, one of
Interesting.
the Galileo scientists, leading planetary scientists, lost a wager famously about how much water was going to be seen by that probe.
Yeah.
Man.
I did some of my research in grad school was studying snowpack and energy transfer in snowpack and like how snow algae live in snowpack
Whoa.
and how they move in it because they when the snow goes away they desiccate and just like are in the ground, but then when the snow builds up they migrate up through the like water in the snow, and it depends on light and water content and snow content.
It sounds like the aliens in the three-body problem.
I haven't watched that. But
Well,
maybe that's where they got the inspiration.
Maybe from your undergrad thesis or something.
But part of the reason this is grad school, but part of the reason we were doing this was to understand energy transfer and how that might apply to places like Mars, where we know there's old snowpack,
Right.
and there's still buried snowpack in
Right.
areas. So
yeah.
maybe relevant to this.
Stay tuned.
Stay tuned.
Which is the largest of these things, Audrey?
God.
Say them again.
The number of grains of sand on Earth,
5,
the number of stars in the observable universe,
7,
the number of molecules in a drop of water,
Question mark.
the number of neural connections in the human brain,
0.
and the number of living cells on Earth.
12.
So your answer is the last one.
I was
12 is bigger than those other numbers.
That's right.
I was only half listening. I feel like
Just like our listeners.
Great.
Just kidding.
I feel like
We love you, listeners.
molecules in a drop.
Molecules in a drop of water.
That was going to be my answer too.
You can both give the same answer.
But she said 12 for the last one.
I did say question mark.
Drop
for that
of water
one.
was the one I didn't answer. Yeah.
Yeah.
Drop of water.
You're both going with drop of water.
Sure.
Drop of water is in the middle.
Good. We're so average.
It's the number of living cells on
I
Earth.
was going to switch to that one. You said 12. You should have gone with it.
Yeah, it does
which
seem
is
like a lot.
about 10 million times more than the number of stars in the observable universe, which is the second biggest.
There's a lot of crap here. How come it's so hard to find everywhere else?
Right?
There's so many cells.
We haven't found a single cell anywhere else, and we've got 10 to the 30th,
That's so many.
We should
give
share.
or take,
I think we probably have
here on Earth.
panspermia. I'm sure we've
Right.
shared.
We've sent some to the moon anyway,
Yeah, that's true.
That's a
And
start.
Mars.
and Mars.
And a couple asteroids
Maybe-
now.
Yeah, probably, yeah.
All right.
Just for funsies, which is the smallest, do you think?
It's
of
not the
those.
drop of water.
No drop of water.
And it's not the number of living cells.
Sand? No.
Stars.
What was the other one? What were the other two?
Stars in the universe, grains of sand on the Earth, and neural connections in the human brain.
Neural connections.
I think, yeah, neural connections.
It is the
smallest.
number. Yeah.
0.
It's still a big number.
Sure.
It's 10 to the 14, which is a
Lot.
100,000 billion, if you want, or 100 trillion.
I don't want
If
to.
you want to do it that way.
I do like 100 trillion. That's
Yeah.
fine.
Okay. Well, while it may have felt like counting all the stars in the Milky Way, it was just another episode of Walkabout the Galaxy. Give us 5 stars on your podcast platform and we'll give you the universe.
Be sure to follow us on Facebook and Instagram to get all our updates. Subscribe to our YouTube channel and catch up on old episodes wherever you get your podcasts.
Our theme music and soon-to-arrive sound effects were composed by Richard Jarusik. Production assistance is provided by Logan Basinger.
I thought those sound effects were going to arrive today, but it's not quite yet.
We can make our
I'm
own.
going to record. We can.
I know.
I'm going to record laser sounds. Let's hear the laser sound.
Pew, pew, pew.
Okay, that's good. I got others, and I'm just going to use them from this recording.
Oh man, maybe we do them later.
Okay. That's a good one. I don't know what we'll use it for, but thanks to our listeners in Missouri and around the world. Stay safe. I'm Josh Caldwell.
I'm Addie Dove.
And I'm Audrey Martin.
We're the Astroquarks signing off until the next episode of Walkabout the Galaxy.
Dear.